Okay, we've got f and f prime are both given on here. F prime is continuous on the interval. What's the value of the integral of f prime? Ooh, don't we know this? Isn't this equal to fundamental theorem of calculus, f of negative 1 minus f of negative 4, which f of negative 1 is negative 1.5 minus f of negative 4 is 0.75, which would be negative 2.25. Okay, does that make sense? Alright, that's gonna do it. Yep. Next one. 86. Table gives values for velocity moving on the x-axis at t equals 0, particles at the origin, which could be the graph of the position. Okay, so it's at t equals 0, the particles at the origin. So it's not that guy, it's not that guy. Right? This has got to start at the origin. Okay. So the velocity is negative, so that means it starts off going to the left or going in the negative direction. So it's got to start off going in the negative direction. So it's got to be not this one, it's got to be going in the negative direction, so it's one of these two. And then before 1 second, it's heading, well, not before 1 second, at 1 second, its velocity is positive. Okay? And then it heads positive, and then at 4 seconds, the velocity is negative. So I know 1, 2, 3, 4, so 4 seconds, at 3 seconds, the velocity is 0. So what does this mean exactly? Think about that for a sec when we say this, because this is the derivative of this graph, right? This is like f, and this is my f prime. So we're saying the tangent line is 0 at 3. Well, that's going to be this graph right here, isn't it? Does the rest of it make sense, though? Is the velocity negative here? Yeah, the slope of it's negative. You're slowing down, absolutely. Okay, start off negative direction, then turn and go positive. Velocity, 0, and then start going negative again. That's going to be that guy. 27. An object traveling in a straight line has position xt at time t. Initial position here, velocity is this. What's the position at 3? Again, that's going to be an integral at 3, and I know that's the initial position. So can we find, this, normally we'd say, take the definite integral and, take the indefinite integral, use this to find the constant, and then plug 3 into it. But we can't take the integral of that, 1 plus t squared to the 1/3 power dt. Yeah, that's kind of you can't really do that directly, because if I let u equal 1 plus t squared, du is 2t dt, and I don't have any t's to put in, and I can't take out a t, so that doesn't work any. How about this, though? Let's see, we want the position at time t equals 3, and I know from could you do this, though? Could you find this, though? What does this represent? that represents how far it traveled the displacement. See, sometimes we forget that we can do these things with our calculator. Displacement from t equals 0 to 3. See, that's how far it, or where it ends up after 3 seconds, right? Or whatever 3 is. And I know it started at 2, so if I just figure out where it ends up at 3, and I subtract 2 from that, then won't that give me the actual position of where it's at? Or I'm sorry, I should add 2 to it. Okay, in other words, this tells me the distance it travels over the first 3 seconds. Okay, from where it starts to where it ends, not the total distance. In other words, here's the start. It might do this, back and forth. This integral is going to give me that distance. Okay? And then if I take that distance and I just add it to 2 from where it started, then that'll give me the final position. Okay, you probably already know what I'm talking about. It's late and I'm probably just rambling on, so I apologize for that, guys. Alright, so let's go ahead and do that integral. FNINT, so math. I just want to make sure that you really get it. Alright, so cube root, so that's going to be 1/3 power. Parentheses 1 plus x squared raised to the 1/3 comma x comma 0 3. Did I put that in right? Guess what I did? I did derivative again. Be careful doing that. You guys probably never do that. So let's do it again. Sorry. Okay. So the right way you get this, you get 4.512, and if you're fast and you go, oh boy, that's my answer, you have to recognize this is a displacement from 0 to 3. Where does it end up? Well, it started at 2, so it went 4.512 from where it started, so its ending position is 2 plus 4.512, which is 6.512. Okay, 88. Radius of a sphere is decreasing at 2 centimeters per second. Okay, that's dr dt is -2. The instant when the radius is 3, what is the rate of change in square centimeters per second of the surface area? And they tell you that, 4 pi r squared. So what's the surface area dt? Is 8 pi r times dr dt. You guys would never forget the chain rule. And that's equal to 8 pi. We want to know the rate of change of the surface area when r is 3 times -2. So 8 times 3 is 24, times 2 is -48 pi square centimeters. There we go. Okay. Function is continuous, -2 to 2, and we've got it's 0 at the endpoints. Okay, so here, pictures are nice when you can help you see what's going on. It's f of 2, f of 0. If there's no c for which f prime is 0, which must be true. So f is continuous. So in other words, it's connected from here to here, right? So if it just, whatever it is, but there's no c where the derivative is 0. So what does that mean? See, however I draw it, there's going to be a c where the derivative is 0. So what keeps that from happening? Well, let's see what the choices are. For k between 2 and 2, f of k is always positive. But that means it's always increasing. But then it doesn't drop down to here. So that doesn't make sense. For negative, let me see one. For in here, f of k exists. For in here, f prime of k exists, but f prime is not continuous. For some k, f prime does not exist. Ding, ding, ding. Because it's got to go like this, like that. Continuous, but there's a corner there where there's no derivative, but the derivative doesn't exist. Not differentiable. 90. Let's see. F is continuous on the closed interval. 2, 4, twice differentiable. On the open interval, f prime is 3, 2, f double prime is negative on 2, 4, so that just means it's concave down, which could be a table of values. Okay, these ones always just seem to take longer. Okay, so we know and the functions, they go from 2, 3, 4, f prime of 3 is 2, so I don't know what the y value is, but I know it's the slope is, the tangent line there is, has a slope of 2, and it's concave down everywhere on here, so concave down, and it goes through that point. That's a tangent line. Okay, so what could be a table of values? That's just a possible drawing to help me understand this. So 2, 2.5, 3.5, 6.5, and it's kind of recognizing this. If this has a slope of 2, then, and this is 1 over, then this has to be 2 up. So here's my tangent line. So this has to be 2 up from here. And this is going to have to be 2 units down for this y value. Okay, I'm just kind of marking stuff that I get from the tangent line, so because I'm comparing my y values. So 2.5, 5, 6.5. So if this is 5, let's just look at this first one. If this is 5, then this has to be, this right here is 7. Okay. Could f of x be 7, for instance? No, not if this is tangent and it's concave down. Right? This can't be concave down, tangent, and go through this point. So I know that's not going to be a possibility. And that one's not going to be a possibility for the same reason, and that one's not a possibility for the same reason. Okay, let's look at the low end. Because see, we've got 5s on all of these right here, right? What about the low end? This has to be, this is 5, it's got to be over 1 and down 2, so that's going to have to be 3. Okay. Could this point be 3 on the curve? If this is, again, if this is tangent and concave down, there's no way it's going to be 3. So that's done. So that's our only candidate, right? This is 2.5 at 2. This is 5, and this is 6.5. That gives me this nice concave down picture right here. Something like that. Okay? Just kind of looking at it and thinking it through. And looks like the last 2 problems here. Average value. 1 over b minus a, integral a to b, f of x dx. 1 over 3 plus 1 minus a negative from, negative 1 to 3 cosine of x over x squared squared plus x plus 2 dx. Obviously a calculated question. I'm going to pause it while I do it. Okay, I just did it, and I got this to be 0.732. Be careful, because then you got to divide it by 4, because then, oops, in our haste, it's easy to do. So divided by 4, you get 0.183. Okay. And number 92, the city is located beside a river has rectangular boundary, population density along a strip. X miles from the river's edge is f of x people per square mile, which gives the population of the city. Okay, people per square mile. Let's see here. Okay, this is a interesting problem, because it's the population density of the city at any point along a strip x miles from the river's edge. So here's my strip dx wide, x miles away. This is, the density is going to be, is f of x. So population density is people per square mile. But if I just multiply that times dx, this distance here, this dx, and when I integrate it, it's going to give me from 0 to 4, it's going to be miles times people per square mile. It's not going to give me people, because I'll still have to think about my units here. I need to have square miles. So I have to multiply it by this length as well, so I can get the times 7 times miles, because that's how long this is going to be. When I multiply by dx or integrate by dx, that's going to give me this dimension, but I have to take care of the other one as well. So the population will be the integral from 0 to 4 of the density times 7 dx. Okay, because that's the density at a point, times 7, that's going to give me this measurement times dx. Okay, it's probably the best way to think of it. So B. So there you go. That's it.